Welcome back, everyone. We are in the second video of about Facebook that talks about human to computer interaction as well. So, we will continue with the concepts that we've talked about in the previous or in the recent video or the one that we've talked yesterday. Um, Designing the product of framework and refinement. So here we will discuss how do we design product from the ground up. I know we've discussed this in the previous videos, but here we will gonna get a clearer version of it. So first, creating the design framework. We want to stay at a high level and concern ourselves with the overall structure of the user interface and associated behaviors. We call this phase of the goal-directed process the design framework. If you were designing a house at this point, would be concerned with what rooms the house should have, where they should be positioned, and roughly how big they should be. We should not be worried about the precise measurement of each room or things like the doorknobs, faucets, and countertops. So here, when we're starting the design, we want to get the high level overview before we get into the details. So this is the main clarity. Instead of focusing on the frameworks or iterating from details to zooming out, here it made it clear that we need to start with a higher level to get the details right. The design framework defines the overall structure of the user's experience. This includes the underlying organizing principles and the arrangement of functional elements on the screen, workflows, interactive behaviors, and the visual and form languages used to express information, functionality, and brand identity. In our experience, form and behavior must be designed in concert. So here we discuss all the or the overall structure, including the functional elements, which we will gonna dig deep later, the arrangement of it, the workflows, the behaviors, and the visual and form languages. Later we will discuss this visual and form language as well, and the brand identity. So the brand identity, it's like a keyword to your brand, the tone of your brand. Later we're gonna dig deep on that. At this phase in the project, interaction designers use scenarios and requirements to create rough sketches of screens and behaviors that make up the interaction framework. Concurrently, visual designers used visual language studies to develop a visual design framework that is commonly expressed as a detailed rendering of a single screen archetype. So here in the previous video we discussed the framework in which we use different frameworks for different situations. Here we use this goal oriented design to be our framework. So here we're gonna before we talk about framework, in which the framework is the one we used in each scenario, but here we're gonna dig deep on how do we actually create a framework. So we start that with high level framework. Concurrently, there is a visual designer that tailor that high level framework of interaction design to the specified screen or specify specific device or environment that our product will be used. When it comes to the design of complex behaviors and interactions, we've found that focusing too early on pixel pushing, widget design, and specific interactions can get in the way of effectively designing a comprehensive framework in which all the product's behavior can fit. So, designing a widget, a pixel, is not actually how design works. So, those can actually get in the way if you do that early because we're designing a complex product. So, here we will gonna see how we make this complex products such as web apps or mobile apps uh, easy because we break it down in smaller steps. Instead, we should take a top-down approach, concerning ourselves first with the big picture and rendering our solutions without specific detail in a low-fidelity manner. Doing so can ensure that we and our stakeholders focus initially on the fundamentals, serving the persona's goals and requirements. So this is the secret. You start with low fidelity manner that serves the persona, goals, and requirements. So this is how you create complex products. The trick then is to render the solution in only enough detail to provoke engaged consideration without spending too much time on or effort elaborating details that are certain to be modified or abandoned. So a lot of things that make designing complex product is thinking about details that may be modified or be wasted. So if we just think about the small steps and then be adaptable for that to evolve, we progress at the same time. We remove a lot of waste of cognitive energy. We found that sketch, like storyboards of context and screens, accompanied by narrative in the form of scenarios, are highly effective way to explore and discuss design solutions without creating undue overload and inertia. So inertia, again, it disrupts flow or momentum. While we believe that usability testing and user feedback are often most constructive during design refinement, sometimes they are useful as early as the framework phase. More discussion of usability testing can be found later. Defining the interaction framework. So here our example or the high level overview of what we will discuss. The interaction framework defines not only the high level structure of screen layout, but also the product's flow, behavior, and organization. It occurs in iterative loops. In particular, steps 3 and through 5 may be switched depending on the designer's thought process. More on this later. The 6 steps are described in the following sections. So here, define form factor, posture, and input methods. Then, determine functional and data elements. And then, determine functional groups and hierarchy. So, in essence, you determine what apps or are you gonna create a website, or are you gonna create a mobile app? Are you gonna create a kiosk? So these are the form factors. And then what's your input method? And what posture is that? Is that a sovereign application or is it a transient application? Determine functional and data elements. So we will gonna choose 2 to 3 functions and data elements. So these functions are the objects where your user can enter an input that will produce an output. Determine functional groups in hierarchy. This is where you group functions, related functions for easier use. And then sketch the interaction framework, construct key path scenarios. So key path, we will gonna discuss that. Check designs with validation scenarios. So here's we will gonna test it. But here we will not I think this is the last. We will gonna skip the testing part because we've discussed a lot of this in evaluation. We will just touch it multiple times during this, but I want to go on the visual design chapter because it's great, guys. So I think you're gonna like it as well. So this you're gonna learn a lot on that about how graphic design, not graphic, um, designers or art designers specifically because I like arts, design arts and how designers in general think about, or visual designers think about cognitive load or interfaces. Define form factor, posture, and input methods. Is it a web application that will be viewed on a high resolution computer screen? Is it a phone? Sorry. By the way, the reason why we're gonna skip because that's part of this. As I said, we are doing this design process from high level frameworks. So we also designed concurrently. We also designed the visuals of it in this phase. So, is it a web application that will be viewed on a high resolution computer screen? Is it a phone that must be small, light, low resolution, and visible in both bright sunlight and the dark? Is it a kiosk that must be rugged to withstand a public environment while accommodating thousands of distracted novice users? What constraints does each of these form factors imply for any design? Each has clear implications for the product design, and answering this question sets the stage for all subsequent design efforts. So, answering this will determine the other design decision, not the other way around. So, the order is important. If the answer isn't obvious, look to your personas and scenarios to better understand the ideal usage, context, and environment. As you define the form, you should also define the product basic posture and determine the system's input methods. The input method is how users will interact with the product. This is driven by the form factor and posture, as well as by personas, attributes, aptitudes, and preferences. So as you can see, this input method is done after you create this high-level posture and the form factor. So this input or data element are driven by this. So it's interconnected basically. Decide which combination is sorry about that. Decide which combination is appropriate for your primary and secondary personas. We will discuss that in the future videos, but basically that's your main users. If you need to use a combination of input methods such as the common website or desktop applications that relies on both mouse and keyboard input, decide on the product's primary input method. So here you're gonna actually decide that. How will your product interact? Is it through mouse, keyboard? Is it through remote control? Is it through motorcycle? It should be hand brake or hand clutch if it's a motorcycle, right? Define functional and data elements. Functional and data elements represent functionality and information that are revealed to the user in the interface. So, these are the functions that you see that you can click on a website, the things that made you accomplish your goal. So this is where you put input and output. So just a moment. Sorry about that. So, whereas the requirements were purposely described in general terms from the persona's perspectives, functional and data elements are described in the language of user interface representations. So, you are describing how the representation of the interface to the user. So while in personas, we've discussed this in the previous videos, but we will gonna discuss a more detailed persona topic. But basically, these functions and data elements are based on that. Kind of like in HTML videos, where it's HTML elements are what we see on the screen. So that you can think of that as the function and data elements, where you have that input and output. It is important to note that each element must be defined in response to specific requirements defined earlier. Data elements, these objects such as photos, email messages, customer records, or orders, are the basic units to be referred to, responded to and acted on by the people using the product. Ideally, they should fit with the persona's mental models. At this point, it is critical to comprehensively catalog the data objects because the product's functionality is commonly defined in relation to them. So you may think that you will define data uh, before you define function, but actually you need to catalog or categorize those data, because that will serve as the basis of your function. So how do you gonna process it to provide the output to the user? You start with the input. We are also concerned with the object's significant attributes, such as the sender of an email message or the date a photo was taken, but it's less important to be comprehensive about the attributes at this point. As long as you have an idea whether the personas care about a few attributes or a lot, so you shouldn't worry about this, because developer will gonna take care of the implementation of this. The attributes or the properties of an email message, or the date photo was taken, and other attributes as well. In the future videos, we will discuss that specifically for data storage. But basically, this is the how the computer thinks about this input and methods, which is through attributes. It's useful to consider the relationships between data elements. Sometimes a data object may contain other data objects. Example of such relationships include a photo within an album, a song within a playlist, or an individual bill within a customer record. These relationships can be documented as simply as creating indented bulleted list. So this is actually how developers start creating their app. They start with database, but in this case, actually, the design and developer have different motivation, but we will discuss that later. But basically, that's the main idea. They start with data. So later you will gonna see, or in time, you will gonna understand it. For more complex relationships, more elaborate box and arrow diagrams may be appropriate. It can be helpful at this point to involve your team's software architect here, who can use the goal-directed data model to create a more formal data object model for later use by developers. So this is what I was talking about it later. In time, you're gonna understand. So the developer or the software architect and the designers that collects the data that can be get using input to the users are gonna talk about. So in the high level view, the designers will talk, or the start of the development, the designers and developer will talk. So usually it is provided by front end developer if there's no designer. So functional elements. Functional elements are the operations that can be done to the data elements and their representation in the interface. So this is how you make these requirements real via operations. So functions is nothing more than operations. Could be plus, addition, minus, or combination of both that provides multiple and sophisticated operations or functions that provide or meet the goal of the user. Generally speaking, they include tools to act on ways to visually and structurally manage data elements. So it reduces cognitive load because it allows the user a structured and visual way to manage their data elements. The translation of functional requirements into functional elements is where we start making the design concrete. This is where we begin to make the difference, that experience real. It is common for a single requirement to necessitate multiple interface elements. For example, Vivian, our persona for a smartphone from chapter 4, which we're gonna discuss in the future video, needs to be able to call her contacts. So these are the example of the functional requirements that we're gonna turn to functional elements. Voice activation, voice data associated with the contact, assignable quick dial buttons, selecting a contact from a list, selecting a contact from an email header, appointment or memo, auto-assigning a call button in the appropriate context, for example, for an upcoming appointment. So the way you actually create now a front end is you specify this task, this individual steps that may be hard to articulate at first, but it provides a solid grounding about what the application needs to do. And after that, you can just chat GPT or vibe code this and then input that in the computer. So that's how you develop codes. It's interrelated with how you design interactive products. So this is where design principles and patterns begin to become a useful way to arrive at effective solutions without reinventing the wheel. So this is where the design patterns are principle, because a lot of the solution are already there. You just need to find what you need or what the customer needs, and then integrate that solution to your application. Ask yourself, which of the possible solution is most likely to do the following: accomplish user goals most efficiently, best fit your design principles, fit within technology or cost parameters, possibly differentiate the interaction from the competition, best fit other requirements. So this is actually how designers create their or became full stack developer after ChatGPT, because they were able to articulate these goals and then make these goals concrete using a technical or code. Pretend the product is human. As you saw in chapter 4, pretending that a tool, product, or system is magic is a powerful way to imagine the ideal user experience to be reflected in concept level context scenario. In a nutshell, interactions with the digital system should be similar in tone and helpfulness to interactions with a polite, considerate human, as you determine the interactions and behavior along with the functional elements and groupings. You should ask yourself these questions. So, what would a helpful human do? What would a thoughtful, considerate interaction feel like? Does the product treat the primary persona humanely? How can the software help full information without getting in the way? How can it minimize the persona's effort in reaching his goals? So, how can we remove excise, which we provide in the previous video? How can the software remove excise and not disrupt flow and help the customer? So this are the another way of saying these questions. So the software recognize the cognitive limitation of the customer, which we've discussed in the previous chapter, and we will also gonna discuss that this cognitive, because those are the principles. That's why we are starting in these chapters in the book. So um, so how can you provide that magic? So magic is actually just understanding the flow on the user or human tendency to achieve flow, and then our motivation to achieve a goal. So later we will gonna dig deep on that. You we've discussed. I think that are the thing. Those are the things that we haven't dig dive in the previous human to computer interaction book. So tone and helpfulness, we will gonna describe as well on how we create a tone on our app. As you determine the interaction and behavior along with the functional elements and groupings. So while you're developing this interaction and the functional elements, because right now we're determining the high level overview that will be the basis of our development, which is the functional elements. You should ask this to have a better understanding of the higher level overview. For example, a mobile phone that behaves like a considerate person knows that after you've completed the call with a number that isn't in your contacts, you may want to save the number. Apply principles and patterns critical to translating requirements into functional elements, as well as grouping these elements and exploring detailed behavior in scenarios and storyboards is applying general interaction principles and specific interaction patterns. So, we discuss how grouping functional elements uh, will help. So we will discuss this further here. And then exploring detailed behavior in scenarios and the storyboards. Storyboards could be a slides of different pictures of the narrative of how the process achieves its goal. Another thing that will help us is the already existing algorithms or patterns that solve the same problems with the previous users or previous designers use. These tools leverage years of interaction design experience of designers working on similar problems. Neglecting to take advantage of such knowledge means wasting time on problems whose solutions are well known. Additionally, deviating from standard design patterns can create a product where users must learn every interaction idiom from scratch rather than recognizing behaviors from other products and leveraging their own experience. Scenarios provide an inherently top-down approach to interaction design. So scenarios start with the top-down. That's why it allow us to be clear on what we are actually designing, because it is coming from zoom out to zoom in. They iterate through successively more detailed design structures from main screen down to tiny sub panes or dialogues. So this design is effective because that it iterates from zoom out, from personas, to more detailed design structures from main screens down to sub panes or panes, and then sub panes or dialogues, which we discussed in the previous video. Principles and patterns add a more bottom-up approach to balance the process. So these principles and patterns, however, are coming from the bottom to up. Principles and patterns can be used to organize elements at all levels of the design. So in each step of the design process, these patterns allow us to organize our thoughts, categorize things, to group things in while we're doing the design. Kind of like how basics always allow you to be grounded because you're always started from there. That's how the patterns and principles look like. Determine functional groups and hierarchy. begin to group functions units and determine their hierarchy. Because these elements facilitate specific tasks, the idea is to group elements to best facilitates the persona flow, both within a task and between related tasks. So these are the what's missing in the previous book that we've discussed is the concept of grouping the functions to their task so that you can achieve flow. Here are some issues to consider. Which elements need a large amount of screen real estate and which do not? So which HTML element uh, consumes a lot of real estate? Which elements are containers for other elements? So which are the nested elements? Because remember HTML elements, this is how we uh, transform our JavaScript function, which we discussed in the previous videos. So which are nested elements? Remember, we manage like large data using this programming language, but it's not intuitive for most people to think. How should containers be arranged to optimize flow? So how would you design that elements in the back end to optimize workflow? Which elements are used together and which are not? In what sequence will a set of related elements be used? So the order is again important, especially for this detailed elements. What data elements would be useful for the persona to know or reference at each decision? So for example, the time would may be helpful when the customer are doing this type of task so that he always see it on his screen, or what other things like that that will help or reduce your customer's cognitive load. What interaction patterns and principles apply? How do the persona's mental models affect organization? So base also the culture on or the uh, previous findings you've got from persona research. What is their mental models and how would you fit your design on that? So based on that knowledge, at this point it's important to organize data and functions into top level container elements such as screens, frames, and panes. So here is the most common top level elements: screen, frames, and panes. These groupings may change somewhat as the design evolves, particularly as you sketch the interface, but still useful to provisionally sort elements into groups. So this, you may not need panes or screens, but these are the top level elements, or you can think of this as sub panes uh, of the details, because again the top level elements are uh, the input methods and the form. Again, intended list or simple Venn diagrams are appropriate at this point for documenting this relationship. So it's the step or the part where it's useful to use a Venn diagram. Consider which primary screen or state, which we'll call views, the product requires. So what is the primary screen? 2 to 3 primary state that your product requires. Initial context scenarios give you a feel for what this might be. So you can write this down based on your persona. If you know that the user has several end goals where data and functionality don't overlap, it might be reasonable to define separate views to address them. So remember, you should have at maximum 2 to 4 views, and then if those functions and data is not related, based on your imagination of what the interaction could be, or based on your user research, it might be better to separate that as long as it doesn't disrupt flow. On the other hand, if you see a cluster of related needs, for example, to make an appointment or to review nearby restaurants, or if your persona needs to see a calendar and contacts, you might consider defining a view that incorporates all this. So here, the making an appointment and reviewing nearby restaurants, or if your persona needs to use a calendar and contacts, you might group that to not disper rough flow. When grouping functional and data elements, consider how they should be arranged given the product's platform, posture, screen size, form factor, and input methods. Containers for objects that must be compared or used together should be adjacent. So later, we will discuss this, the how you can actually visually make your product sequential using adjacent pins. Objects representing steps in a process should, in general, be adjacent and ordered sequentially. So objects, remember, that's just an elements. If it's related, it should be represented adjacently. Yeah, and also if it's sequential. Additionally, I just want to remind you guys that uh, these are just an aesthetics to complement what Don Norman are saying, that though some products could achieve what you want, such as its functions, but if it has a lot of aesthetics issues, such as cognitive load or excise, then it will uh, uh, in the future it will become unusable. Now here, sketch the interaction framework. Then after that, around the studio, we often call this the rectangle phase. Our sketches start by subdividing each view into rough rectangular areas corresponding to panes. Control components such as toolbars and other top level containers as shown in figure 5.2. So remember the toolbar where the user or intermediate user put their most commonly used. So panes is not accident that we always use this term, because this is how we uh, design LCD or screens today, whether it's for phones and websites. So we divide it via rectangles or pins. Label the rectangles and illustrate and describe how one grouping or element affects others. Draw arrows from one set of rectangles to others to represent flows or state change. So here in each box, you have these different elements there, right? So that consists your HTML element, the input and output. So you can draw an arrow that will relate that to a different square on the screen. So this is actually how you design to implementing a website or an app, whether it's mobile or in whether other things from the ground up. So an early framework sketch from designer Cooper created for cross-country travel cords, an online portal for traveling nurses. Framework sketches should be simple, starting with rectangular names and brief descriptions of relationships between functional areas. So here, it's simple, and then it starts with a rectangle. You should have names and a brief description of its relationship between these areas. Details can be visually hinted at to give an idea of the contents, but don't fall into the trap of designing detail at this stage. This visualization of the interface should be simple at first, boxes representing each functional group and or container with the names and descriptions of the relationship between different areas. Be sure to look at the entire top level framework first. Don't become distracted by the details of a particular area of the interface. Although imagining what goes into each container will help you decide how to arrange elements and allocate real estate. So, by if you're a developer and also a designer, it will allow you to design, because you see the full stack or the system level of what's happening. Because you know the details, such as what elements or how you can implement this. Trying to do so too soon may risk creating a lack of coherence in the design as you move forward. Because often, like, designer though is not a developer, so that's why the book says this. Trying to do so may risk creating a lack of coherence. We will discuss this in the visual design later, on how to create a coherent theme on the app. Sketching the framework in an interactive process that is best performed with a small collaborative group. This group includes one or two interaction designers, or ideally an interaction designer and a design communicator. Someone who thinks in terms of the design narrative, and a visual or industrial designer. So you want a small group, or for this, one or two interaction designer and a design communicator, someone who thinks of visual design, sorry, an interaction and a visual or interaction design. In recent years, we've also grown fond of using tablet computers with OneNote connected to a shared monitor for our initial sketches. So basically, the main idea of this, anything that will make the collaboration easy and fast, is preferable. So right now, there's tools like Miro that allows you to collaborate in just one application. It is also critical to be easily render several related sequential screen states to depict the product's behavior in the keypath scenario. So states we define here as a keypath. Later we will discuss that. So it's important on this collaboration to categorize or group this related and sequential screen state to show the product behavior. The states construct in Fireworks makes it particularly good for doing this. So construct keypath scenarios, or this is the keypath scenarios. These scenarios depict the primary pathways through the interface that the persona takes with the greatest frequency, often on a daily basis. For example, in an email application, keypath activities include viewing and composing email, not configuring new mail server. These scenarios typically evolve from the context scenarios, but here we specifically describe the persona's interaction with the various functional and data elements that make up the interaction framework. So after we create these functional data elements and we organize that, now it's time to think about the key functions or the key paths, because the paths could have multiple functions, remember, that your user does in your website. So this is for email, including viewing and composing email, not configuring. We've discussed this in exercise that this type of functions must be removed from the users. So usually these are evolved from context scenario, but here we're just trying to describe personas interactions based on the functional and data elements that we have created. Again, we're just creating this high level overview. So we sketch the framework, we group it. Now we're trying to imagine the most useful paths that the user took. As we add more and more detail to the interaction framework, we iterate the key path scenarios to reflect this detail in greater specificity around user actions and product responses. Unlike the goal-oriented context scenarios, key path scenarios are more task-oriented. So unlike the persona, which would determine the life goal, the behavior, and then the end goal, or something like that. Yes, but it's like the high-level overview of the goal. Now we're talking about the task. In this way, they are similar to agile use cases. This doesn't mean that we can ignore the details. Unlike the goal-oriented context scenarios, key path scenarios are more task-oriented, focusing on task details broadly described and hinted at in the context scenarios. Goals and persona needs are the constant measuring stick throughout the design process, used to trim unnecessary tasks and streamline necessary ones. So you can think of path as well as task. Those tasks could change, but the goal does not change, right? I mean, it could change, but it really change compared to task, because there's multiple ways to do or to achieve your goal. As we discuss in exercise, you must rigorously remove task that you have created that does not serve your user goals. Storyboarding. So these are the ways to create these keypads. This technique of storyboarding is borrowed from filmmaking and cartooning, where a similar process is used to plan and evaluate ideas without having to deal with the cost and labor of shooting actual film. Each interaction between the user and the product can be portrayed on one or more frames or slides. Advancing through them provides a reality check of the interaction's coherence and flow. So, again, we're trying to create now the details, but essentially we're still on the top part of the product. We're not yet creating the detail part or the physical ones. We're not yet deciding how big our panes or how big our frame, our page or view is. We're not designing the function yet. We're just imagining it using these tools, the storyboarding. And then by doing these details, storyboarding, it allows us to understand it more. What the tasks are actually excised and what is not excised. So advancing through them provides a reality check of the interaction's coherence and flow. Does it actually really provide flow? Because we don't really know if this provide flow without actually checking or doing something, right? So it's kind of like an initial check. You can think of that, though we have a separate topic on that. Process variations and iterations. It is common to move back and forth between steps and to iterate the whole process several times until you have a solid design solution. Depending on how you think, you have a couple of different ways to approach step 3 through 5. You may find that one works better for you than another. So here is the fifth step. So 3 is categorizing. So you can jumble this depending on your personality. So a more evolved framework rendering from the cross-country Travcorp's job search web application. So this is the recent more developed concept for this is a wireframe. So here's an example. Verbal thinkers may want to use the scenario to drive the process and approach step 3 through 5 in the following sequence. First, keypad scenarios, and then after that, work out the groupings verbally, then sketch. Visual thinkers may find that starting from illustration will help them make sense of other parts of the process. They may find this easier. Sorry about that. Sketch and then keypad scenarios. See if your groupings work with scenarios. So there's still grouping, there's still catch, but for visual you start with sketch. For verbal, you work out the groupings verbally. So instead of this, seeing your groupings with scenarios, you see that verbally. I personally am a verbal thinker, so this is the difference with the previous book that we have discussed. Is that this different? I think we've discussed that it's just in different ways, but here you make it clear that you have this top-down approach process that is more clear or more what do you call this? More rigid. Check designs with validation scenarios. So here, after you have storyboarded your key path scenarios and adjusted the interaction framework until the scenario flows smoothly and you're confident that you're headed in the right direction, it is time to shift focus to less frequent or less important interactions. This phase consists of asking a series of what-if questions. The goal is to poke holes in the design and adjust it as needed, or throw it out and start over. You should address three major categories of validation scenarios in the following chapter. So, in this case, we're almost basically done. So, we have a coherent, because again, we started with the personas and then top level. Now, we're getting in the details. We're just asking here what are the things that is the edge cases, uh, or the little or the not so important, but still important, right? So this phase consists of asking, alternative scenarios or alternative or less traveled interactions. It is the scenario that split off from key pathways at some point along the persona's decision tree. This could include commonly encountered exceptions, less frequently used tools and views, and variations or additional scenarios based on the goals and needs of secondary persona. So it could be an additional scenarios that you didn't get from the persona analysis, or it could be tools and other tools, third-party tools and views that you may want to add based on that use cases. So these are the typical uh, additional comment of your not so common users, such as an expert scenario that suggests another functionality with the product. Necessary use scenarios, it include actions that must be performed but only infrequently. So from the word itself, purging database, upgrading device, configuring, and making other exceptional requests may fall into this category. So this is where you provide like demonic application, where the step are needed, but you only use that infrequently. It's not really like the function that you always click or use, or the user use. Users may forget how to access the function or how to perform tasks related to it. So it's like a transient application. You can put this transient use into a demonic application, or you can make it a transient application, depending on your use case or the availability. However, this rare use means that users won't require parallel interaction idioms, such as keyboard equivalents, nor do such functions need to be user customizable. So this rare use is acceptable to not to create your new idiom or not familiar function. An example of a necessary use scenario for the design of a smartphone is if the phone was sold second-hand, requiring the removal of all personal information associated with the original owner. Edge case use scenario. Edge case should never be the focus of the design effort. Designers can ignore edge case functions and situations, but the interaction needed for them is of much lower priority and usually is buried deep in the interface. Although the code may succeed or fail on its capability to successfully handle edge cases, the product will succeed or fail on its capability to successfully handle daily use and necessary use cases. Defining the visual design framework. So here we're gonna go deep. This is what I'm talking about. As the interface framework establishes an overall structure for product behavior and for the form as it relates to behavior, a parallel process focused on the visual and industrial design is also necessary to prepare for detailed design unless you're working with a well-established visual style. This process follows a trajectory similar to the interaction framework, in that the solution is first considered at a high level and then narrows to an increasingly granular focus. Develop experience attributes. So the first step in defining a visual design framework, to choose a set of 3 to 5 adjectives that will be used to help define the tone, voice, and brand promise of the product. There is a strategy discussion to have if these attributes don't fit the person's goals and interests. This set of descriptive keywords are collaboratively called experience attributes. Visual designers usually lead the development of experience attributes, as interaction designers are more accustomed to thinking about the product's behavior than the brand. It's often a good idea to involve stakeholders in this process, or at least get their input at the onset. So visual designer is different than interaction designer, because visual is more like the afterwards of the interaction design process, and a visual design is usually a constant and dependent on the interaction design. Gather any existing brand guidelines, familiarize yourself with them. If the company has clear brand guidelines, build around one product, the product you're designing, much of your work may have already been done for you. Gather together examples of strongly branded products, interface objects, and services, including multiple examples from a particular domains, will help stakeholders think about their differences. If we include images of cars, for instance, we might include examples from BMW, Toyota, Ferrari, and Tesla. Work with stakeholders to identify direct and indirect competition. Gather example of these products and services, products and interfaces to include in your examples. So usually, if you're working with a familiar brand or established brand, they already have this style, so they've done all the work with you. But if because you can follow their standards or guides, which we're gonna talk deeply later. But if you don't, you need to work with stakeholders to identify direct and indirect competition. So if you don't, you need to find competition or competitors and gather example of the product and services, products, and interface to include in your examples. Pull relevant terms mentioned by interviewees in the course of your qualitative research. So in this case, since you don't have this established style, you need to pull that yourself, navigate the personas research, or sometimes you need to do this research yourself. Pay particular attention to any pain points mentioned. For instance, if many mention that a competitor or the existing version of the product is hard to use or unintuitive, you may want to discuss whether friendly, easy, or understandable should be an attribute. So you're getting these three words, or these keywords that describe your product. With the brand guidelines, example products, competition, and user notes on display to reference, have a discussion with stakeholders about the sub-brand of the product you're designing. So it's like a sub-pain because you're categorizing, right? We often ask stakeholders to vote for and against examples by placing red or green stickers on them, and then discuss any clear winners, losers, or controversial examples. From the outcomes of this discussion, identify the minimum number of adjectives that define and distinguish the product. So you need to be clear about the tone or the main tone of the product, but at the same time you want to as minimal as possible, because any extra fight with limited screen or prioritization technique. If any of the words have multiple meanings, document the exact sense intended. Sharp, for instance, could refer to precision and sleekness, or it could mean intelligent and wit. Consider competitors. If your set of attributes does not distinguish the brand from competitors, refine them until they do. Also, make sure that individual attributes are aspirational. Smart is good, brilliant is better. Check back with the stakeholders and especially any marketers on your proposed attribute set to discuss and finalize them before moving forward. So you need to do the research for the competitors, for their visual design, and then identify their attributes. Make sure your attributes distinguish you from your competitors. Check back with the stakeholders, especially any marketers. So you need to check back on them on your proposed attributes to set and finalize it. Develop visual language studies. Now, this is the second step. These studies are based on experience attributes and include color, type, and widget treatments. They also include the overall dimensionality and any material properties of the interface. For example, does it feel like glass or paper? So here in the studies, you need to like feel it or to check the material properties on how it feels, like the if it is it curvy, is it flat. These studies should show these aspects abstractly and independent of the interaction design, because our goal is to assess the overall tone and suitability for general interaction. So our goal is to determine if that attribute that we've found and then apply it into more detailed like color, type, and widget uh, is suitable for the tone that we want. So it's kind of like an A/B testing, trying to check what color, type, widget is gonna fit. Commonly, a company's brand guidelines form a good starting point for this activity. But it should be noted that brand guidelines rarely consider the interactive experience and may not account for the difference in multiple software products. So sometimes a company may have guidelines already, so you can start from there, but sometimes those guidelines are not may not account for the complexity of the software products. Brand guidelines commonly consist of a document explaining how a company's brand identity should be conveyed visually and textually. Substantial work is required to translate a style guide for marketing collateral into meaningful look and feel for an interactive product or website. So a lot of work is required for translating that into a product. So a guide from a company is takes a lot of work to be in the interactive product, especially if you consider the marketing, because you need to also consider the technical constraints and how you would sell it. It's also important to consider environmental factors and persona aptitudes when devising visual styles. Screen that just must be visible under bright lights or from a distance require high contrast and more saturated color. So high contrast or more saturated color uh, uh, is also needs to be considered. So the elderly and other sight impaired users require larger and more readable typefaces. So this is a little different from our approach to interaction design, in which a product is usually one optimal behavior framework. So it's different in the optimizing interaction or the behavior. Visually, several different styles all can be considered with experience keywords and goals. So here we can visually check different styles using that experience keywords, because we have one key theme. Unlike in interaction design, it's more complex to know because it's an iterative process. Using experience attributes to develop these approaches helps move stakeholders away from personal tastes and biases by providing a vocabulary for an experience that is in sync with brand's meaning. It is often useful to develop one or two extreme options that push the look and feel a bit too far in one direction. Doing this makes it easier to differentiate between the various approaches and helps stakeholders choose an appropriate direction. So you can go too far just to provide a comparison, because comparison is a really good way to explain things that your stakeholder may not notice. So never show a design approach you're unhappy with. Stakeholder just might like it. So don't show them design that you don't like, because they might like it, or most often they will choose it. It's important to contextualize them in terms of these goals and keywords, and to describe the rationale for each direction and its relative merits. So later we will discuss how having this rationale in each icons, in each design, in each things that we visually see on the screen are important when designing. We ask stakeholders to first give us their initial emotional reaction and then walk through things in a more rational fashion. So we ask them as stakeholders to give us the initial emotional reactions and then talk through things in a more rational fashion. Then after that, we use these experience attributes to talk and discuss with the stakeholders. After apply the chosen visual style to the screen archetype. So depending on the screen that we've chose, we will gonna apply now this visual style. The final step is to apply one or two selected visual styles to key screens. So in the 2 to 3 main view, we will gonna apply this to try. We typically coordinate our visual and interaction design efforts so that this step is performed close to the end of the interaction framework. So we apply this visual after the interaction design or the first framework that we've done. At that point, the design has begun to stabilize and sufficient specific details reflects the visual style. So it's like the front end now. So we started from the back end on what's really the main uh, beast of our product. Now we're just like, filtering the design. The further refines the visual style so that this further refines the visual style so that it reflects key behaviors and the information. So we want to reflect the key behaviors and information we want to see on the product. By making the design more concrete, you can better assess the feasibility of the proposed solution without the overhead of updating numerous screens for each minor change. So it's kind of like having low fidelity prototype. Those low fidelity could be would be put into trash, but it's still important to have this effort to make that concrete because it allows us to assess the feasibility if that's actually possible. Again, we start with the design and then with the interaction design and then visually trying to do it one step at a time to check the feasibility. So it's still important to, for example, if you are working with a client, it's still important for you to promise less. So you're not gonna worry about the feasibility so much because you can always add more features. So it provides you an option. So yes, it makes you anti-fragile. Defining the industrial framework. So let's see. So here, I'm just gonna take a, a P, just a moment. So, thank you for waiting. So the now we're gonna get into more concrete. So we'll just finish this and then we'll skip this and then go to the visual design. So the reason I want to include this in a visual design is part of designing a product is you want to be concrete with the physical appearance. Now, defining the industrial design framework, we developed the industrial design framework in much the same way as the visual design framework. So it has more similarities in visual design than interaction design. But because the form factor and input method have significant implications for both the industrial and interaction design, it's useful to collaborate early on to identify relevant issues. So at the same time, you can currently design this. So as you can see, you are designing three at the same time. A visual design, interaction, and this industrial, because you want the form factor and input method to be technically feasible. That's why having this developer as a designer is really valuable, because you get these three designers at the same time. Collaborative with interaction designers about form factor and input method. So if the product you are designing relies on custom hardware, as with cell phone or medical device, it is important for interaction designers and industrial designers to agree on a general physical form and input methods. So they need to agree with the acceptable with the interaction designers. So these decisions include the product's general size and shape, the screen size, if any, the number and general orientation of hard and soft buttons, and whether the product has a touch or multi-touch screen, keyboard, voice recognition, motion or position tracking, and so on. This collaboration typically start with a couple of days at the whiteboard in a condensed set of scenarios. So here, you check the orientation of the hard and soft buttons and whether the product has multi-touch keyboard, voice recognition, motion, or position tracking, and so on. So kind of like in your thesis, right? Before you create a product, you want to be sure that it's technically feasible. So usually the AI today, or the thesis for computer science, they are about the voice recognition. So you want to be able to agree with the panels that you will add that, and then if that is actually technically feasible, for example mobile apps, etc. Now important things to consider when making this decision include persona experience goals, see chapter 3, attitudes, aptitudes, and environmental factors, as well as brand and experience keywords, market research, manufacturing cost, and pricing targets. So you will need to consider the persona again, environmental, um, experience keyword that you got from visual design, market research, manufacturing costs, etc. Because the cost of a hinge can make or break the margin on hardware, and because internal components such as battery can have tremendous impact on form, an early sanity check with mechanical and electrical engineers is critical. There's only one user experience, and it comes from the combination of the physical form and the product's interactive behavior. So the one experience, the reason why we're combining this is because the experience includes the physical form, not just the interactive behavior. The two must be designed in concert, and according to the adage of modern architecture, form should follow function. So the demands of interaction must guide the industrial design. So form should follow functions, like the data should follow the function. So before you create the function, you need to decide what's required. Otherwise, and then what's the screen real estate limitation. Otherwise, you're designing function that is not related to data. So you need to group data, relate the function to that, categorize, sketch it, and then have this one visual attribute. So that's how you create this full stack product. The two must be designed in the demands of interaction must guide the industrial design. About fabrication and cost will also impact the possibilities available to interaction design. Now, there is only one user experience. Form and behavior must be designed in concert. Develop rough prototypes. It is often the case that even after the overall form and input methods are defined, the industrial designer still can take a variety of approaches. For example, when we've designed office phones and medical devices, it's often been asked whether the screen angle should be fixed or if it should be adjusted, and if so, how that will be accomplished. Each one has different cost and ergonomic consideration. Just a moment, guys. I just let's take a break for like 3 minutes. I'm just gonna sip tea. Alright, guys. I don't want to break the momentum, so let's continue. So develop rough prototypes. It is often the case that even after the overall form and input methods are defined, the industrial designer still can take a variety of approaches. For example, when we design office phones and medical devices, it's often been asked whether the screen angle should be fixed or it should be adjustable, and if so, how that uh, will be accomplished. Each one has different cost and ergonomic considerations. Even after we define this input and form, an industrial designer can still take a variety of approaches for this prototypes. So here, after we've designed already the office phone, we still ask if it's should be adjustable. So it's basically like as we've discussed in the previous videos, we've dig deep in this. I would suggest you going back on that, on how we actually develop this prototype. So develop form language studies in a fashion similar to the visual language studies described earlier. The next step is to explore a variety of physical styles. Unlike the visual language studies, these are not abstract composite. Instead, they represent various looks applied to the specific form factors and input mechanisms determined in step 1 and 2. So, these are a bit different or different from visual language that um, these visual language studies represent various looks applied to the specific form factors and input mechanism. So before we've tried different styles, but now we're relating it on our physical input and the out of physical form factors and input. These studies include shape, dimensionality, materials, control, and finish of that form factor and input. Typically, these studies require several rounds of iteration to find feasible and desirable solutions. So here in this industrial design, you're actually trying to check if your interaction design are feasible. So you're exploring different physical styles available, kind of like in the discovering requirements, finding the available options available in the because a lot of times, like what I've said before in the previous book, is that we're not aware of the options. So not we're just trying to find or explore different industrial design. So these are not abstract components, but actually a physical one. So the reason why we stop, or we took a break, because these are long topic as well. So the reason why I combined this in one video and then I skip the other is because it's just an important, and discussing this in one video covers a lot of the topic of the books, because we've touched or explained a bit of that of the most of the concepts. So here I find it helpful as well, because it reduces again a lot of cognitive load by understanding this. So this visual design, again, in the initial part, we're creating a high level overview. So we're doing visual design, interactive design, and industrial design to make sure that our product is feasible. Now, this is actually the deeper level of visual design. So remember the aesthetics. This is how most customers wants, because it reduces their cognitive load. Kind of like how it makes them visually attractive. So anything that's visually attractive always win. So Apple did not actually provide more functionality. It provides more visual attractiveness to its users. So this is how we make it. So integrating visual design. These efforts will fall short unless you also dedicate significant work to clearly communicating to your users both what content is available and how they can interact with it. With interactive products, this communication almost always happen visually via a display. So some products do not actually require you to see it because it's running on the background, just like what this discussed, demonic applications. But if you're designing like a product that will be used visually, which is will certainly almost all the uh, visible or the interactive products that you can see is actually visual because we're a visual being, you know. We learn through like we've discussed, the most cognitive load that we do is visual. So even if you describe your interactive design clearly, if you don't have this visual um, form that will enable your user to communicate it, it will eventually fail. So, understanding this is crucial with interactive products. With interactive products, this communication almost always happen visually via a display. With custom hardware, you can also communicate some product behavior through physical properties. So those are different sense because you could think of this as a sense of touch. Now, visual art and visual design. Practitioners of fine art and practitioners of visual design share a visual medium. However, while both must be skilled and knowledgeable about that medium, their work serves different ends. Art is a means of self expression on topics of emotional or intellectual concern to the artist, and sometimes to society at large. So, I think one of the best artists here in the Philippines is Tito Sota. So, he is great. He finished a Bachelor of Arts, major in English. He is great in this. Uh, expression on topics of emotional or intellectual concern or language or performing arts. It's about determining the timing, etc. Sometimes to society at large. Few constraints are imposed on the artist, and the more singular and unique the product of the artist's exertions, the highly it is valued. So, uh, it has a different value for art designer and then for an applied art. So designers, on the other hand, or the applied art, concern of contemporary artists is concern of contemporary artists is primarily self-expression. Visual designers are concerned uh, with clear communication. So here, instead of art, which is vague or more few constraints with the language, here you want to be as precise as possible. So you can think of the art, not applied art, as a unclear or vague or high level. But for this applied art, you have this more detailed, so it's clear communication. Daryl Sano note in their book Designing Visual Interface in 1994, design is concerned with finding the representation best suited to the communication of some specific information. So it's you could think of it at applying the right interface at the right framework, or creating framework based on situation. In keeping with the goal-directed approach, visual designers should endeavor to present behavior and information in such a way that is understandable and useful, supporting the organization's branding objectives as well as the persona's goal. So, since we need to keep on this interaction design we've mentioned earlier and the goal-directed approach, uh, they should endeavor to present the behavior and information that is understandable. So, if the product or going to be useful to some people based on their goals, then they need to present it to help the users understand it better, to use the product easily, seamlessly. You want to remove this cognitive load. Supporting the organization's branding objectives as well as the persona's goals. So the branding, we've discussed that. So there's key attributes. To be clear, this approach does not exclude aesthetic concerns, but rather places such concerns within a goal-directed framework. So it's not the same as goal-directed framework, because the goal, you're focusing on the function. Now you're focusing on the aesthetics or the CSS of the website. So previously we've discussed how functionality was created by JavaScript, and then the style or the visual are created by CSS. So now you're focusing on the CSS or the style. Although visual communication always involves some subjective judgment, we endeavor to minimize questions of taste. We found that the clear articulation of user experience goals and business objectives is an invaluable foundation to designing the aspects of an interface in support of brand identity, user experience, and emotional response. So the reason you want to start with the function or the persona or the interaction design first, because this visual design are inherently subjective, kind of like an art or a novel, creating a novel. The right thing are different to different people. It's like a framework that it depends on different circumstances. So there's no right, really no generalization or no right thing. It just depends on the goal. So that's why a good user or research is the foundation, or the good the start is always the will dictate how you will end, right? Because you need to always start in the end. So that's why you need to get it right, because in interaction design, right, you start with the high level before you get into the details. So those details or these details are dependent on that high level. So we found that the clear articulation of user experience goals, etc. So the elements of visual interface design. At its root, visual interface design is concerned with the treatment and arrangement of visual elements to communicate behavior and information. So we also discussed this in the interaction design, but now we will gonna dig deep. So it's about the order, the arrangement is important. This is the visual interface design. So now instead of arranging the design of buildings, or the architect design of buildings or art, or the organization or the order of how it is designed, now we're designing things or elements on the screen, the HTML element and the information in it. Every element in a visual composition has a number of properties, such as shape and color, that work together to create meaning. So shape and color is actually a properties that you see on your screen. The way in which these properties are applied to each element and how they change over time and with interaction allow users to make sense of content and graphical interface. So in the previous book, we discussed how the interfaces that we use solves most of the problem, because it allows us to make sense. Now, this is actually how we create those interface. Visual design is also a study of those interfaces and how they change over time. So it's about the study or those application or combination of those properties, such as shape and color, applied to each element on the screen. For example, when two interfaces object share the same color, users assume they are related or similar. When two objects have contrasting colors, users assume the objects have some categorical difference. Visual interface design capitalizes on the human ability to differentiate between objects by distinct visual appearance, and in so doing creates meaning that is richer than the use of words alone. So, so visual design is using of these objects, like it technically uh, capitalizing with our visual capability, because we are visual beings. So uh, the reason why I mentioned that the comparison is very important, because this is how we associate meaning. You know, if everything is important, or if everything is not, if it's the same, then kind of like the our visual is not um, useful, right? So here it allows us, this visual allows us to understand things even if we're not reading. uh, it allows us to understanding things faster. So it allows us to recognize object. So what are the principles of this, or the elements? Context, context, context. Every single visual design guideline is subject to the context in which it is used. Are your users doing information work on large screen desktop computers with overhead lighting? Are they standing in a dark room, scanning the screen for the tiniest of biological details? Are they walking across a city, holding your design in the glare of the sun? Are they cuddled up on a couch, just playing around? Similar to conveying the brand, which we discussed earlier, the context of use must be taken as part of the given that constraint the visual design. So we've kind of touched, we've touched of this multiple times. As you can see, these elements are also the elements of interaction design. So they are interconnected. Shape, so again, and also in the previous book, this is also a key theme about framework, that it's all about context, context, context. Shape is the primary way we recognize what an object is. We tend to recognize objects by their outlines. A silhouette of pineapples that's been textured with blue fur still reads as pineapple. However, distinguishing among different shapes takes a higher level of attention than distinguishing some other properties such as color or size. This means it's not the best property to contrast when your purpose is to capture the user's attention. So if you want to capture attention, you should not use shape, uh, because it takes a higher level of attention. It kind of like distract the flow. Additionally, the difference with this book is that it dig into the details of this visuals. Unlike with the previous book we've discussed, it's more broad. It's kind of like applied on different products. Now, it mainly concerned with these screens, which is kind of like more useful in a way, because a lot of us, you could argue that a lot of us use screens, to make us productive, because as we've discussed in the previous book, we've translate this all most of our physical task into digital. So this weakness of a shape as a factor in object recognition is apparent to anyone who's glanced at Apple OS X dock and mistakenly select the round iTunes icon instead of the round iDVD icon, or latch onto the photo in iWeb and mistook it for iPhoto. So another thing is the icon. So those are actually shaped. So some icons, as we will later learn, is that could provide a double functionality. It could provide you, such as in Microsoft, provide like an icon or this shape that stands for two functionality. So we can also do that. We can take advantage of this. This is how we use this visual design. These icons have these different shapes, but they are of similar size, color, and texture. Size, how big or small is it? Sorry. How big or small is it in relation to other items on the screen? Larger items draw our attention more, particularly when they're much larger than similar things around them. Size is also an ordered and quantitative variable, which means that people automatically sequence objects in terms of their size and tend to assign relative quantities to those differences. So these are the difference with the previous book, in that this size not just allow get our attention, but it is often used to order things to determine what's the more important. But it is not as attention grabber than shape. So, if we have four sizes of text, for example, we assume that relative importance increases with size and that bolded content is more important than regular. This makes size a useful property in conveying information hierarchies. More on them in a minute. So the information hierarchies, especially in these screens that we use or product that we use, is so useful. In his classic, The Semiology of Graphics, University of Wisconsin Press, 1983, Jacques describes size as dissociative property, which means that when something is very small or very large, it can be difficult to decipher other variables, such as shape. So, if it's so large, other variables such as shape could be hard to decipher. So variables are the things that change in the screen or in this interactive products. Color. Though most people speak of color loosely, designer must be very precise and deliberate when considering colors in an interface. Any choices should first take into account the user's goals, environment, the content, and the brand. After that, it's most useful to think of interface color in terms of value, hue, and saturation. So after you define that, I think we've mentioned this multiple times, the goals. It's just about manipulating this value, hue, and saturation, which is HSV actually, that determine the differences on the importance of the icons or the elements of our on our screen. Value. Of course, the idea of lightness or darkness is meaningful primarily in the context of an object compared to the background. So the lightness and darkness only matters depending on background. As you can see, it's related to the comparison of size and then shape. So the color only matters depending on the background color, because we compare it using visual. On a dark background, dark type is faint, whereas on a light background, dark type is pronounced. Like size, value can be dissociative. If a photo is too dark or too light, for example, you can no longer perceive other details about it. So if you are conveying detailed information, then if it's too dark or too light, then you can no longer perceive other details. So you miss the point of the function. So the interaction design or the goal actually distract the user. So later we will discuss how we're manipulating these variables or elements for us to actually help the user based on their goals. People perceive contrast in value quickly and easily. So value can be good tool for drawing attention to elements that need to stand out. So people see this value of this color, or when we manipulate this, they see that quickly. So it is a useful tool to determine what's important on your product. Value is also an ordered variable. For example, lower value, darker colors on a map are easy to interpret as deeper water or dense population. Hue. Is it yellow, red, or orange? Great differences in hue draw our attention quickly, but users often have multi-layered associations with who. In some professions, who has specific meaning we can take advantage of. For example, an accountant sees red as negative and black as positive. And at least in Western systems we're familiar with, a securities trader sees blue as buy and red as sell. So the yellow, red, and orange depend on the culture and also depend on the audience. If your audience is color blinded, then it might not. You should act accordingly. To Westerners who've grown up with traffic signals, red means stop and sometimes even danger. Whereas in China, red is the color of good luck. Similarly, white is associated with purity and peace in the West, but with funerals and death in Asia. Unlike size or value, though, who is not intrinsically ordered or quantitative. So it's less ideal for conveying that sort of data. So the difference of this with who and then value, it's not order and or you cannot quantify it. So it's less ideal for conveying that sort of data that value could easily express. Color is best used judicially to convey important meaning in an interface to create an effective visual system that allow users to keep track of implied meanings. You should use a limited number of whos. Yeah, whos. So basically, since the color are used to imply or to convey meaning, to create an effective less cognitive load screen interface that allows user to keep track of the meaning that you want to provide, you should use a limited number of this. The carnival effect of having crowded color palette overwhelm users and limits your ability to communicate. So you may think like having a lot of color palette is gonna make your product expressive, but later you're gonna see that there's only 2 to 3 simple things, and then most often than not, you just need to emphasize those 2 to 3 simple things or functions, 2 to 3 windows, 2 to 3 views that operates your website or application. Who is also tricky since color blindness is common among the general population, and there are many types of color blindness. Saturation. Saturation draws attention similar to the way that who and value do. That is, when there's a strong contrast at play, saturation is it also play like the value in which the there's a strong contrast that draw users' attention. So saturation is quantitative in that greater saturation ties tightly to higher values. So it's like value. The higher it is, the higher the value. So those saturated colors can imply excitement and dynamism. It can also read as loud and cacophonous. The carnival effect mentioned above can be exacerbated with too much saturation across the palette and compete with the actual content. So again, we don't want to distract flow. So this color, you may think that increasing this contrast or getting their attention through these techniques actually disrupt the flow. HSB in combination, who, saturation, and value are 3 variables that together can be described any color in an interface in a model sensibly named HSV. So using these 3 elements, we can actually define any color that we want. So we can make it light, dark, depending on our brand. Another common system, RGB, lets designers specify the red, green, and value styles for a given color. So again, this is just CSS. Actually, we define this through CSS. or more commonly now using CSS processors. Designers should be judicious in how they use contrast within these variables, as well as how they relate across entire palette. Orientation, is it pointing up, down, or sideways? This is a useful variable to employ when you have directional information to convey. Up or down, backward or forward. Orientation can be difficult to perceive with some shapes or at small sizes, though, so it's best used as a secondary communication vector. So it only used as a secondary, other than, I mean, we mostly use color because for small size and some shape actually does not convey, or we can't make sense of the orientation, but it can be used as a communication tool as well. For example, if you want to show that the stock market is going down in a single graphic, you might want to use downward pointing arrow. That's also right. So again, we're still on the elements of the visual design. Texture. So these are the things, or the visual things, that how we make sense of the world without actually reading the words, right? Is it rough or smooth, regular or uneven? Of course, elements on a screen don't have a real texture, but they can have the appearance of it. So again, in industrial design, this is where the texture more applicable, because we're concerning the physical. But since we're dealing with LCD, we're just talking about 2D. Texture is seldom useful for conveying difference or calling attention, since it requires a lot of attention to distinguish. uh, Textures also takes a fair number of pixels and higher color resolutions to convey. So we started from the highest attention grabber, which is shape. Now here, texture is actually less and less attention grabber, but it's still useful. However, it can be an important affordance cue. When we see a texture grabber area on a physical device, we assume that's where we're meant to grab it. So an affordance cue is like making the input or function obvious, so it can be used, still can be used in a LCD interface. Ridges or bumps on a user interface or UI element generally indicate that it's draggable, and the bevel or drop shadow on a button makes it seem more clickable. The current fashion for flat or non-skeuomorphic design has brought about a diminished use of texture or simulated materiality. So, since we moved from mechanical to idioms, this has been less and less used because we don't rely to the things that we always see before digital age. But we have found that even in a highly minimalist design, a small amount of texture applied appropriately can greatly improve the learnability of a user interface. So this can be used to improve the learnability, but it's not as attention grabber. But later you will see that we don't need to grab the attention as much as the most common function. So these are the elements, could be just a subtle difference that allows us to not disrupt the user flow and then to achieve our brand goals. Position. Where is the where is it relative to other elements like size? Position is both an ordered and quantitative variable, which means it's useful for conveying information about hierarchy. So a position of this, like the position in the pins, is highly valuable in determining how is it related to others. So you can use this as well to easily make sense of your screen. You can leverage screen reading order to locate elements sequentially. For Western readers, this put the most important or first use elements in the top left. Position can also be used to create spatial relationship between objects on the screen and objects in the physical world, as often happens with medical and piloting interface. So in essence, these are elements. This is actually how the world that we see works. It's a combination of these object elements, position, size, etc. Right, and then the position in the physical world as well determine how we understand it. Right, spatial relationships can in turn be used to allude conceptual relationships. Items that are grouped together on the screen are interpreted to be similar. So these are highly used, as we have discussed earlier, in interaction design, right? The functions, we group it. So based on the position, we determine or we make sense of this. So these are highly visual activity that allows us to easily understand it without reading the words. The use of spatial positioning to express logical relationships can be further enhanced with motion. So motion, as we will later see, is an effective way to grab our attention as well. In the Mail app on iOS, the horizontal animation that transition from the inbox to an individual email helps reinforce the logical hierarchy that is used to organize the application. Text and typography. Written language can convey dense and nuanced information, but you must be careful to use text appropriately because it also has great potential to confuse and complicate. So because text is deeper, it can also mean complication. And remember, not all people read increasingly complex books. So yeah, people recognize words primarily by their shapes. The more distinct the shape, the easier the word is to recognize, which is why words typed in all capital letters are harder to read than a mixture of upper and lower case. So again, it goes back to the elements of shape. It distracts us. It also applies in words. So the familiar pattern matching hints of words shaped are absent in capitalized words. So we must pay closer attention to decipher what is written. Recognizing word is also different from reading, in which we scan the lines of text and interpret the meaning of words in context. Interfaces should try to minimize the amount of text that must be read in order to use it successfully. So again, since we are visual creature, so not all of us actually are reading increasingly complex books because that's harder for our brain. Design principle visually show what textually tell which. Okay. So provide a visual or picture for them to easily make sense of it. So basically, you're removing the cognitive load. You're just helping them to achieve their function. So these are the things or the elements that we can like manipulate. So think of this as a variable on the screen that we can change based on the user goal. Sometimes we want the user to we want to challenge the user, especially in games. But for this, we can remove the excise by designing these variables in balance that will help us to create a usable interface. When text must be read in interfaces, the following guidelines apply. Use high contrast text. Make sure that the text contrasts with its background and do not use complementary colors that may affect readability. We aim for 80% contrast as a general rule. So make sure that the text contrasts with its background. And then it do not use complementary colors that may affect readability. So make sure the background does not have this distracting color with the text. So you want to provide 80% contrast if you will need a text. So choose an appropriate typeface and size. In general, a crisp sans serif font such as Verdana or Tahoma is your best for readability. Serif typefaces such as Times and Georgia can appear hairy on screen, but this can be mitigated with very high resolution displays using a large enough size and sub-pixel fonts smoothing technologies. So some fonts are hairy but could be mitigated by high resolution displays. I think that's not a problem nowadays because there's a lot of high quality devices at low price. Type sizes of less than 10 pixels are difficult to read in most situations. So 10 pixels, I think that converts to like 8 pt in a word, because the sizes in word is pt. Phrase your text succinctly. Make your text understandable by using the fewest words necessary to clearly convey meaning. Also, try to avoid abbreviations. So, use as few words as necessary. So, unlike this, what I'm doing, I mean, before I group these words, I try to remove unnecessary things as much as possible. So, like prune, 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 or it's the same like in salient information, clean, clean, clean. It's also applicable here. Makes it sufficient, because overly uh, too much words could complicate and confuse. Information hierarchy. This is another element, kind of like related to position. So again, it's interconnected. When users are presented with a visual interface, they go through an unconscious process of evaluating the most important object or information there, and what relationships are between it and other visible content and control. So this is oh god, Control Z. So this is actually how our visual perception work. So we find the most important, because otherwise everything is important and we get distracted. So if you don't have these visual capabilities of sensing or removing the noise, it actually makes us it's really hard to live. So here, what it does is that it find the most important, and then what the relationship are between it and other visible content and controls, and other visible size, shape, color, controls, how it is or position, etc. To make this decoding process as quick and easy as possible for users, Visual Designer create information hierarchy using differences in visual attributes: large versus small, light versus dark, top versus bottom, etc., to stratify the interface. For transient applications, the information hierarchy should be very apparent, with strong contrast between the levels of importance in a given layout. So information hierarchy is especially useful for transient or rarely used application. So here we combine a lot of the elements we've discussed earlier: the size, the color, whether the position, etc. You can think of this as combination of those. For transient application, the information hierarchy should be very apparent with strong contrast. So last element in visual design: motion and changes over time. Any of the elements mentioned in this section can change over time to convey information. Relationship between parts, command attentions, is transition between modes, confirm the effects of command. So it's kind of like in a physical world, where your memory, when you focus on something, you only see few information that you focus on, or few objects, and then those objects change over time, and those could create like a completely different elements, or completely different elements or information. That's why it's words are complex, right? So as you can see, it's like a highly related with the interaction design, right? It's just we're just digging deep on the concept. It's kind of like networks. I really like the explanation of networks, in which there's really different views in the system, in which that you can there's like a infinite ways to view it, right? Or on what we see. It just depends on what we look at the moment visually, what our memory look visually. So the animation, sorry. In iOS for desktop, for example, elements rarely simply appear and disappear. After clicking an application icon in the dock, it will bounce to confirm the command was received and the application is loading. Minimizing a window doesn't just make it vanish, so the genie animation shrinks and deforms it, sliding into a thumbnail position to one dock. So This is called rich modeless feedback, which is another topic again, but we will touch into this. So basically allowing you to see feedback on screen once you click something. So as you can see, it's just a combination of data elements and this design elements that put into action in the screen. So the animation confirms that the minimize command was received and tells the user exactly where the window waits minimize until the user summons it again. So what makes interface, as you can see, again, what makes an interface usable is not really the technical details in the hardware, but the small cognitive little effort on the screen that the user does. At the same time, those are actually hard to implement in the backend if you're just gonna think about this, because if you are not aware of those cognitive exercise in the first place, it's kind of hard to do it or to express it technically, because again, you didn't put that into words, you just visually see it. And also, even if you visually see it, you might not be aware of this cognitive. That's why design is very important, because it's like a system thinking, or it's so useful. Visual interface design principles. So we're gonna discuss this. So you can see it's a lot. The principle is a lot. GHIJ. So a lot of like things that is useful in this book. It's just the details of this visual design. That's why if we cover this, we've got most of this already. So visual, I mean, we've discussed a lot of these design principles earlier and as well in the previous video in exercise, but now we will gonna get more. Okay, so the human brain is a powerful pattern recognition computer, making sense of the dense quantities of visual information that bombard us everywhere we look. Our brains manage the overwhelming amount of data flowing into our eyes by discerning visual patterns and establishing priorities to the things we see. This in turn allows us to make sense of the visual world. Pattern recognition is what allows us to process visual information so quickly. For example, imagine manually calculating the trajectory of a thrown baseball to predict where it lands. With pen and paper, you need a formula and measurement of its path, speed, and wind. But our eyes and brains together do it in a split second without conscious effort on our part. To most effectively convey the behavior of an application to users, visual interface designers should be taking advantage of users' innate visual processing ability. So it's not really about like the technical abilities, because it just makes sense cognitively to focus on visual or aesthetics. It's not that you're not providing the user function. It's just that this is visually, we are visual being, so we achieve a lot using this visual mode. So it's actually not subjective if you will base it in your goal directive, because we're a visual being. We save a lot of cognitive energy, we understand a lot visually. That's why this also makes sense to that people use these products because of visually, not because of politics, but it leverage a lot of our cognitive, so it makes us do more with less. Convey a tone or communicate the brand. So we've discussed this, like the key attributes. More and more interactive systems are the main way through which customers experience brands. So while the brand consideration should never override users' goals, an effective interface should embody the brand promise of its product line and organization, because it provides consistency. So the user doesn't have to think about what's the main thing. It's kind of like providing one point. So this can be tricky if the company doesn't have it well articulated. It's rarely, if ever, communicated explicitly in marketing and advertising materials. And younger or smaller companies may not have had a chance to identify what it is. Cooper works with its client to help identify experience attributes, a collection of handful of adjectives that together describe how any interaction through the product or service should feel. So we just discussed that uh, on how these are created. These attributes are often presented as word cloud that includes smaller words that help inflect or disambiguate the attributes themselves. So these are the reason why we continue with this, is because these are related, right? The attributes. Most often, this is directly affects the visual design, but can also be used to guide interaction designers when designing between uh, functionally similar design. So it actually serves as a guide. So we go back to interaction design when designing between functionally similar design. So, for example, like same function could have the same design for the user to organize it. So that simple change actually helps us a lot, and especially if it's a sovereign application, because we are visual being. If you notice, it's the same pattern, so we easily do the task, right? So we achieve more with less. The attributes sometimes express tension between its words. Secure and nimble might be in the same cloud. For example, these are useful tension, as early style studies can optimize for one or two of the experience attributes. These make them in turn easier to distinguish and discuss with stakeholders and show how it relates to the brand. So just like an icon could serve a two different functions at the same time, this principle helps us organize, at the same time helps us communicate with the stakeholders and show how it relates to the brand. So it influences them easily because you communicate it clearly, so that it less cognitive load for everyone. Kind of like how communication help you to learn because you're able to teach it. At the same time, it also reduces other people's cognitive load, and you're able to make them better because you're able to teach them at the same time. Lead users through the visual hierarchy. In looking at any set of visual elements, users unconsciously ask themselves, what's important here? Followed almost immediately by, how are these things related? We need to make sure our users' interfaces provide answers to both of these questions by creating hierarchy and establishing relationships. So you need to answer those questions to the user for them to easily get the point, and not disrupt flow. Based on scenarios, determine which controls and bits of data users need to understand instantly, which are secondary and which are needed only by exception. This ranking informs the visual hierarchy. Next, use the basic visual elements, position, color, size, etc. to distinguish levels of hierarchy. Kinda like sorting is the most useful algorithms. Hierarchy is also important because it's also how we visually do it. We determine what's important and what's the relationship of this to achieve what we think is most important. The most important elements could be larger, have greater contrast in hue, saturation, and or value in relation to the background. So we can now manipulate these variables to satisfy these principles and be positioned above and indented or outdented in relation to other items. So indentation can be used as well, a bullet list, a nested list, etc. You can name it. Less important elements could be less saturated, have less value, and who contrast against the background. Again, value, who, and saturation could be less if it's less important and should be smaller than and placed in consistent alignment with other items. So this is how we use those design elements. Of course, you should adjust these properties with restraint, since the most important element doesn't need to be huge, red, and outdented. So sometimes you don't need a lot of contrast, because depending on your so if it's sovereign application, you want this to not disrupt flow. If you overly communicated it through color or through size, it may do harm than good. Often varying just one of these properties does the trick. So this is what I'm saying. You only have 2 to 3 functions that is most useful. So often one of these as well, or 1 to 2 of this as well, is enough. If you find that two of items of different importance are competing for attention, it's often a good approach to turn down the less important one rather than turn up the more important. So you also need to, again, prioritize the sort. Another way of thinking about this is if you see two same style and then different importance, of course you're gonna prioritize the most important ones because that's the most important algorithm, the prioritization or sorting, right? Sorting algorithm. It takes skill and talent to keep an overall style. Uh, optimize information density and respect the needs of the particular screen. So you in reflective in a previous book in reflective design in which we are considering a lot of factors, so this is the brain that we're using. So it more brain consuming because you have to there's a skill in balancing the overall style, on how to optimize the necessary information, the most useful, how it the density, the color, and respect the needs of particular screen with the technical limitation. Though users almost never notice good visual hierarchy, a bad one will jump out for its confusion and difficulty. So again, you should not disrupt flow. If the user complain, it means you did a bad job. Additional way of looking at it is how politicians balance the budget, right? It takes a skill. It's almost an art that you cannot just say it because it's a lot of different factors. Your morality, your math skills, the political skills, the law, etc. So establish relationships. So because we determine what's important and then how it's relate to other objects to make sense of it. So essentially sorting it and then comparing the importance to other objects. So this is another principles that is just more elaborated or additional way on how we manipulate the data elements variable. To convey which elements are related, return to your scenarios to determine not only which elements have similar functions, but also which elements are used together most often. Elements that tend to be used together generally should be grouped spatially and perhaps sequentially to reinforce conceptual relationships and to minimize mouse movement. Again, the exercise, the mouse, those small little movement of mouse add to our cognitive exercise. So those categorization of that, of the similar function of that elements that we see provides a lot of removal of exercise. So elements that tend to be used together and generally should be grouped spatially and perhaps sequentially to reinforce conceptual relationships and to minimize mouse movements, provides us the stability of relationship. So you may, if we look at objects or just words without a relationship to a sentence or to other objects, if we don't categorize or clean it, it becomes confusing. So the cleaning actually are related to this as well. I forgot where I would say that. So here, you always need to look or clean, assess what's more important, and then to act accordingly to visual hierarchy. It's also the connected, highly connected to this. It's just more deep way of explaining it. So another way to look at this is that books, right, provides a lot of meaning than just words or sentence or paragraphs alone. So it provides, that's the importance of language, right? Allows us to be sophisticated like this. So here, It discussed that the elements should be grouped spatially and perhaps sequentially to reinforce conceptual relationship and to minimize mouse movement. It also kind of like application of interface in more detailed or in screen level or in element or object level on the screen. Elements that aren't necessarily used together but have similar functions may be grouped visually even if they're not grouped spatially. So even if it's not uh, pro- in proximity with each other, we can still group it but by having it the same shape, color, size, etc. Right? Items in proximity to one another generally are related. In many interfaces, this grouping is done in a heavy-handed fashion with bounding boxes everywhere you look, sometimes even around just one or two elements. So make sure that items that are in proximity, since the user will see that and may think that it's important, make sure that it is related. In many interfaces, this grouping is done in a heavy-handed fashion with bounding boxes everywhere you look. So a lot of interfaces use box, to group this or panes, like we've discussed earlier. Sometimes even around just one or two elements. In many cases, you can accomplish these things more effectively with differences in proximity. So you also want to do this in your apps since you only have 2 to 3 panes, and then inside that panes, just make 2 to 3 functions that are related. For example, on a toolbar, perhaps there are 4 pixels between buttons. To group the file commands such as open, new, and save, you could simply leave 8 pixels between the file command buttons and other groups of buttons. So for toolbar, so use a more detailed measure. Perhaps there are 4 pixel between buttons. So 4 pixel, and it will allow the user to immediately see the relationship on what that icon or element or design element are for. To group the file commands such as open, new, and save, you can simply leave 8 pixels between the file command buttons and other groups of buttons. So group items that are not adjacent by giving them common visual properties, for forming a pattern that eventually takes on meaning for users. So after that, the users will develop an idiom that will help them determine. So even just proximity, not even the shape or size, can help you accomplish this. The standard blue links in HTML, for example, make it easy for user to parse a screen for content release navigation options. After you have decided what the groups are and how best to communicate them visually, consider how distinguishable they need to be and how prominent the group needs to appear in the display. So after you have grouped it and then check visually, you always need to test iteratively and consider how they distinguish the option. So better yet, test it with the real user. So occasionally squint at it, close one eye, and squint at the screen with other eye to see which elements pop out, which are fuzzy, and which seems to be grouped. Changing your perspective can often uncover previously undetected issues in layout and composition. So this is where the creative process or your problem solving uh, will help you, because like closing one eyes will help you see things in different way that you haven't thought of before. So that's usually how we solve problems. That's how we debug things. That's how we think of different ways to solve solve a problem. Kind of like in a in different like there's some, I think there's some medicine that will allow you to do that, that allows you to have an ego death, that allows you to see things completely different. So those could be helpful as well, but there's a different really ways to be creative. So provide visual structure and flow at each level of organization. It's useful to think of user interfaces as being composed of visual and behavioral elements, which are used in groups, which are then grouped into panes. So you want to provide flow again and a visual structure uh, at each level of the organization. So in each organization, you have to uh, have this coherent, kind of like in a brand attribute. It's useful to think of user interfaces as being composed of visual and behavioral elements, which are used in groups, which are then grouped into panes, which then may in turn be grouped into screens, views, or pages. So those prints, as you can see, you are organized. You're categorizing the category, and then you're grouping the category, such as you can think of that as panes. In a pane, it can be grouped into screen, a views, or a pages. So those are grouped. You can think of that as group. You're organizing things, right? Because groupings allow us to see the relationship. Make sure you have a flow on that, and then the overall meaning makes sense, and then it follows like really the mental model of the user. These groupings, as discussed earlier, can be accomplished through spacing or shared visual properties. So again, that's one of the most useful distinguisher or visual elements: space, and then visual properties such as size, color, and text. Size, color, and shape. Sovereign applications may have many such level of structure. Therefore, it is critical that you maintain a clear visual structure so that user can easily navigate from one part of your interface to another as his workflow requires. So this is especially useful, this principle, in sovereign uh, application, because many of this structure, because it's critical that you maintain a clear visual structure so that user can easily navigate from one part of your interface to another as his workflow requires. Because the workflow, again, the flow, you want the flow of the work, especially for these productivity tools. These are the unspoken concept, or like more detailed way of looking at it. Align to grid. So these are the techniques that we use to achieve this principle. Group elements should be aligned both horizontally and vertically, as shown in figure 17.1. In general, every element on the screen should be aligned with as many other elements as possible, because you want to save space. The decision not to align elements or group of elements should be made judiciously and always to achieve specific differentiating effect. So Adobe Lightroom makes very effective use of alignment to a layout grid. Text, controls, and control groups are tightly aligned with a consistent atomic spacing grid. It should be noted that the right alignment of controls and control group labels may compromise scannability. So the correct alignment of controls and control group labels may compromise scannability. So you, because you it's the same, since it's organized in the horizontal and vertically, you might not notice things that you want to be noticed, kind of like in critical incident analysis in the previous book. So if you want to differentiate, then this is not applicable. But these are the techniques for us to organize what is already organized screen. So align labels. Labels for controls stuck vertically should be aligned with each other unless labels differ widely in length. Left justification is easier for users to scan than write justification. So a left spacing or labels for controls stuck vertically should be aligned with each other. So label um, that are stuck in vertical position should be aligned with each other. If that label differs widely in length, so let's say example that label that you're working is differ in length, uh, then left justification is easier for users to scan than right justification, because we usually read from left to right, right? Unless you're an Arab, you start at the right uh, of the screen. So align with the set of controls. A related group of checkbox, radio buttons, or text fields should be aligned according to a regular grid. So it should be in a rectangular, they should be grouped. So if it's a for checkbox, then align all checkbox. If it's for radio button, then align that. So those are the techniques to organize what things are already organized. Align across control groups and panes. Groups of controls and other screen elements should all follow the same grid wherever possible. So you also should align the control groups and panes. So the panes that are the same should also be could also be organized. Group of controls and other screens elements should all follow the same grid wherever possible. So if it's the same elements, design elements, so this is kind of like the details of how we organize functions and data elements on the screen. So we group this in the same pane. If it's the same shape, if it's the same size, etc. A grid system is one of the most powerful tools available to the visual designer. Popularized by Swiss typographers in the recent years after World War II. I'm sorry about that. A grid provides a uniform and consistent structure to layout, which is particularly important when you're designing an interface with several levels of visual or functional complexity. So it's kind of like visualizing what's the nested data elements that computer science helped to solve in the background. So grid solves the visual interface organization problem. After interaction designers have defined the overall framework for the application and its user interface elements, as discussed in chapter 5, visual interface designer should help regularize the layout into grid structure. So after they have designed the overall framework of the application, since like in the interaction design, what do you call this, industrial design, visual design, where we structure the high level framework. After that, visual interface designer should help regularize the layout into a grid structure. So again, this is how you make it into details on the screen, because most LCD screen is graphical interface which works in 2D. This is actually the innovation, one of 3 innovation that happens in the recent years in making this complex command lines or books into a graphical interface that helps us see things instead of reading it. It should emphasize the top level elements and structures and provide room for lower level or less important controls. So again, it capitalizes in our sorting algorithm, ICE. So it this grid should be used to emphasize the top level elements, but while also providing the less important. So this is sort of like a technique, a visual technique that allows you to see the important and less important. Typically, the grid divides the screen into several large horizontal and vertical regions as shown here. A well-designed grid employs an atomic grid unit that represents the smallest spacing between elements. So it employs an atomic grid that represents the smallest spacing between elements on the screen, because we're trying to capitalize the
real estate, the small real estate. For example, if your atomic unit is 4 pixel spacing between screen elements and groups will all be in multiple of 4 pixel. This grid ensures regularity across different screens. So not only it organizes the organize, it also provides consistency, which, as you know, new design principle help us to remove cognitive load. It also reduces the amount of work that a designer must do to lay out the screens and the work that the user must do to read and understand the screen. Of course, you must strike a balance between idealized geometric relationships and a specific spatial needs of the functions and informations that you must be presented on screen. So while this technique provides this organization or this consistent hierarchy, you also must strike a balance between your goals, the size or the shape, and the needs of the function that you want to convey. Information that a perfect implementation of the goal in section will do nothing to improve the readability of a screen where things are jumped together with insufficient spacing. Ideally, a grid should have a consistent relationship between different size screen areas. So in an ideal world, a grid should have a consistent relationship between different screens or between different devices. This relationship typically expressed as ratios. Here are three common use ratios. The celebrated goal section, or phi, approximately 1.61, is found frequently in nature and is thought to be particularly pleasing to the human eye. The square root of 2, approximately 1 to 1.14, is the basis of the international paper size standard, the A4 sheet. 4.3 is the aspect ratio of most computer displays. A good layout grid is modular, which means that it should be flexible enough to handle necessary variation while maintaining consistency wherever possible. It's also anti-fragile. If two areas of the screen require approximately the same amount of space, make them exactly the same size. So if it's only approximately that's not the same, make it the same to provide consistency. If two areas have different requirements, make them substantially different to provide extreme. Again, you're trying to make it easier for the visual brain to recognize the difference or relationship. Using a grid system in visual interface, so I noticed something there. So if you want to provide the relationship, you usually want to compare it to other things or to differentiate it with other things. So it's kind of like the opposite, yin and yang, right? Using a grid system in a visual interface design provides several benefits. Usability, because grids attempts to regularize positioning of elements, users can quickly learn where to find key interface elements. If a screen header is always in precisely the same location, the user doesn't have to think or scan to find it. Aesthetic appeal, if you carefully apply an atomic grid and choose the appropriate relationship between the various areas of the screen, your design can create a sense of order that feels comfortable to users. So again, everything on the screen, so like what I've said, should have a rationale or the reason why it's there, because you're optimizing for this limited screen. So if it's organized and coherent, just like a book, how the paragraph should also only have a main point, it also applied here in design. Efficiency. Standardizing your layouts will reduce the amount of labor required to produce high quality visual interfaces. So if you have standard layouts of this, you provide high quality visual interfaces automatically. So you do it at scale. Actually, nowadays we entirely have this entire design language, such as a CSS processor, that allows us to even use this further. This design principle. We find that defining and implementing a grid early in design refinement results in less iteration and tweaking of interface design. Second, create logical path. In addition to precisely following a grid, the layout must properly structure an efficient logical path for users to follow through the interface, like this. So, eye movement across an interface should form a logical path that enables users to efficiently and effectively accomplish goals and tasks. Balance the interface elements. So the elements we've discussed, you need to balance that to achieve your goal. Again, it's a design, it's an art, it's a balance of depending on your goal. Perfectly symmetrical interfaces lack a sense of hierarchy that encourages the user's eye to flow through the screen. So if it's symmetrical, it lack a sense of hierarchy that encourage eyes to flow through the screen. So if everything is important or the elements is used as the same, then it doesn't provide this relationship or hierarchy on what's the most important. Balance asymmetry uh, provides visual entry points to the screen and major screen areas. So it provides an emphasis on the most important so the user can focus its eyes on that. Experienced visual designers are adept at achieving a symmetrical balance by controlling the visual weight of the visual individual elements. Asymmetrical design is difficult to achieve in the context of user interfaces because high premium placed on white space by screen real estate constraints. So again, it's just a kind of different ways of describing it, but this language that helps us describe it in different ways makes us sophisticated and notice this little difference. So signal what users can do on a given screen. A user encountering screen or a function for the first time looks to the visual design to help him determine what he can do on the screen. This is the principle of affordance discussed in chapter 13. So again, in design principles, we're not looking on just we will discuss this affordance, but it also included in integrating visual design chapter. So as you can see, it covers a lot of topics in this book. The affordance as well, you want to make it obvious. So how do you do that? Use icons. In addition to their functional value, icons can play a significant role in conveying the desired brand attributes. So it's like a two-in-one, like the symbol that we've discussed earlier that provides the function value and then provide a brand attributes. Whatever the style, it should be consistent. If some of your icons use bold black lines and rounded corners and others use thin angular lines, the visual style won't hold together. Convey a sense of function. The most significant challenge to represent is to represent an abstract concept in iconic visual language. In these cases, it is best to rely on idioms rather than to force a concrete representation where none makes sense. So this is one of the issues. That's why we have an entire chapter to this. Is that representing an abstract concept in an icon. Since these are abstract, it's like consists of words from the user. We're trying to make it now visual. In this case, we should use idiom. For more obviously concrete functions, some guidelines apply. Represent both the action and an object acted on to improve comprehension. Nouns and verbs are easier to comprehend than verbs alone. For example, a cut command represented by a document with an X through it may be more readily understood than a more metaphorical image of a pair of scissors. Beware of metaphors and representations that may not have the intended meanings for your target audience. So again, the use of metaphors, we touch on how metaphors is not most often not the way the functions that we see on our digital screen now, because it was from a mechanical age. So group related functions to provide context, either spatially or if this is not appropriate, using color, other common visual themes. Keep icons simple, avoid excessive visual detail. Reuse elements when possible so that users need to learn them once only. So again, these are another little abstract details. that we can learn from this is that we can reuse elements, so that instead of contrary to removing, we're now reusing elements so that it provides consistency, and that the user can only shall only need to learn once. So we're basically uh, attributing or using the user's mental model. Third, associate visual symbols with objects. Most applications will need visual symbols to represent objects in the user workflow. So associate that object that has input, process, and output with a visual symbol or shape, right? For example, in a photo management app, each image file is represented by a thumbnail. When the symbols can be representational or metaphoric, they can be idiomatic. So you could represent this object with text alone, such as with a file name, but a unique visual helps an intermediate user locate it on screen quickly. So again, this is what the things that we learn here. We are optimizing for intermediate user. That's why one of the design principle, instead of just like making things organized, etc., we want to provide visual as well as text format for intermediate user, because for text that could be more detailed or could provide more accurate or like a numerical form way for the user, but at the same time it doesn't help the intermediate user what we actually optimizing or up for. So to establish the connection between symbol and object, try to use the symbol whenever the object is represented on screen. So we need to use an icon or symbols with objects. It's particularly important to visually differentiate objects that exhibits different behaviors, such as buttons, sliders, and check boxes. So check boxes, sliders, buttons, that are the symbols that are most commonly used in this 2D graphical interface. So design principle: visually distinguish elements that behave differently, right? So render icons and visual symbols simply. The graphics capability of color screen is now commonly at a very high resolution, so it's tempting to render icons and visuals with ever increasing detail, producing an almost photographic quality. However, this trend ultimately does not serve user goals, especially in productivity applications. Icon should remain simple and schematic, so and minimizing the number of colors uh, and shades, and retaining a modest style. So you may think that size and colors are used to differentiate, especially in sovereign application, but actually the icons for this, it's just enough normal differentiator using simple and schematic. Although fully rendered icons may look great, they tend to fail for a number of reasons. They draw undue attention to themselves. They render poorly at small sizes, meaning that they must take up extra real estate to be legible. They encourage a lack of visual cohesion in the interface because only a small number of functions, mostly those related to hardware, can be adequately represented with such concrete photorealistic image. So again, as we discussed, it removes cohesion and removes the important that disrupt actual flow. Additionally, there's a lot of technical constraints in wanting this photorealistic. So the function that most closely related to the hardware capabilities are the one that is being rendered properly. So pre-visualized results when possible. Instead of using words alone to describe the result of interface functions, or worse, not giving any description, use visual elements to convey users what the results will be. So we're sorry. Okay, so we're applying this associate visual with objects, but now we're previewing it. So as you can see, we're defining this additional step. We pre-visualize this, such as this word. There's a preview. You can still see this, the number size here, but you can remove it, right? Sorry, we can. You know that you can see the what it will look like in physical world, because you provided an additional step other than those design principle of providing objects. You provided also the preview. So Instead of using words alone to describe the result of interface functions or words not giving any description, use visual elements to convey users what the results will be. Don't confuse this with using icons on control affordances. Rather, in addition to using text to communicate a setting or state, render an illustrative picture or diagram that communicates the behavior. So it's not an affordance, it's an obvious way of clicking it, but you're also adding additional state, which is the free view. In recent years, Microsoft has discovered this fact, and the dialogues in Microsoft Words, for example, have begun to bristle with visualization of their meaning in addition to the textual controls. Photoshop and other image manipulation applications have long shown thumbnail previews of the result. Have long shown thumbnail previews of the results of visual processing applications. So in recent years, Microsoft has discovered this fact, and dialogues in Microsoft Word, for example, have begun to bristle with visualization of their meaning in addition to the textual control. So you actually now visualize the meaning of the textual dialogue, because especially if transient application or transient dialog box, it's hard to decipher its meaning. Photoshop and other image manipulation applications have long shown thumbnails previews of the result of visual processing operations. So here, Microsoft Word Print Preview is a good example of visual expression of application functionality. Rather than requiring users to visualize what a 1 to 2 inch margin might look like, this function allows the user to easily understand the ramification of different settings. Microsoft could go one better by allowing direct input on the preview control in addition to output. So allowing users to drag the picture's left margin and watch the numeric value in the corresponding spinner ratchet up and down. The associated text field is still important. You can just replace it with visual one. The text shows the precise values of the settings, whereas the visual control accurately portrays the look of the resulting page. So if you could like manipulate this and then change the field simultaneously. So in the back end, it's different function, but in visual you only see one function. So those are helpful as well, because we are visual creatures. So response to command, we will have another chapter on this. I don't think if we will have, because we've touched of it for this a lot, especially in the previous book. But it's called like rich modeless feedback. So after executing a command from a swipe, tap or click, which is the most useful operations or things we communicate on this LCD, the user needs to see some response to know that the system has heard them. In some cases, the output is instant and immediate. The user selected a new typeface for some selected text, and that text changes to display in the new one. If the response takes longer than a tenth of a second, but less than a second, you will need to provide one subtle visual cue that the command was received, and another when the activity is complete. If a process will take longer than 10 seconds, it's usually best to design an alert explaining the delay. Another for a running state update that lets them know the process is continuing in the background, followed by a respectful cue when the process is completely, so that they can return to the task. So it's kind of like in downloading files nowadays in the browser. You know it's running in the background, so you can do other things. So draw attention to important events. The tools to draw attention involve the fundamentals of human perception and are all based on contrast. Again, it's kind of critical incident analysis or comparison, contrast, differentiating, whatever you call it, as long as you're able to like differentiate it from others. Contrast of size, color, motion, etc. Make things you want to get attention different, and it will command attention. These sound simple, but there are two challenges. The first is that attention getting mechanisms are not under our conscious control. That makes sense when you consider that they evolved to alert us to sudden changes in the environment. Blinking objects command our attention so strongly that it's difficult to pay attention to anything else. The second challenge is that it can be difficult to keep attention signal effective but in line with the experience keywords. So you may want to differentiate, but it could go so far that it may not the experience that we want based on that motivation that Norman provided us, such as the function that the user want to achieve. If your app is meant to be serene, yes, a klaxon will get the user attention, but will also break the promise that the app has made. So it's kind of like a balancing act because you have to consider the goal. At the same time, you have to consider this differentiating technique. Minimize the amount of visual work. Visual noise within an interface is caused by superfluous visual elements that detract from the primary objectives of communicating affordance and information. So, if we want to minimize the visual work, visual noise within an interface is caused by a lot of visual elements such as size, shape, that detract from primary objectives of communicating affordance or the obvious symbols and information, because the user again wants to achieve something such as his goal. So a lot of noise could distract because we're prioritizing things. So we are sorting, algorithm. The same is true for user interfaces. Visual can take many forms: ornament, embellishment, 3D rendering that doesn't add information, rule boxes and other visually heavy elements to separate controls, crowding of elements, intense controls, textures and contrast, using too many colors, weak visual hierarchy. So it's kind of like related again in the salient information and cleaning, because we want to be focused on attention because we are a visual being. So we want to sort it, right? So here, kind of like minimizing those cluttered interfaces attempt to provide an excess of functionality in a constrained space, resulting in controls that visually interfere with each other. Visually baroque, disorderly, or crowded screens increase the user's cognitive load. So, it's just not important in identifying personas' goals or creating a persona. It's also important with their visual or aesthetics, because providing an excess functionality or like an excess in this limited or constrained world or constrained space result in a lot of cognitive load, because remember, we cannot really focus a lot on all things at once because we have like limited memory. And keep it simple. In general, a visual interface should strive to be minimal, such as simple geographic forms or a restricted color palette, composed primarily of less saturated or neutral colors balanced with a few high contrast accent colors that emphasize important information. This is what I'm saying. You only need to have these few things emphasized using these colors. Typography should not vary widely in an interface. Typically, one or two typeface specified to just a few sizes is sufficient for most applications. Unnecessary variation is the enemy of coherent, usable design. It's like dirty is the enemy of clean, right? Every visual element and every difference in color, size, or other visual property should be there for a reason. Good visual interfaces, like any good visual design, are visually efficient. They make the best use of the minimal set of visual and function elements. So they make the best use of this 2 to 3 function and data that the user actually want. That's why they use our product. A popular technique used by both graphic designers and industrial designers is to experiment with removing individual elements to test their contribution to the clarity of the intended message. So it's like cleaning, another way of cleaning, but it has been used by industrial design and then a graphic designer. So take things away until the design breaks, and then put the lasting things back. As pilot and poet Antoine de Saint famously said, Perfection is attained not when there is no longer anything to add, but when there is no longer anything to take away. The more useful work a visual element can accomplish while still retaining clarity, the better. Related to the drive for simplicity is the concept of leverage, which is where a single interface element is used for several related purposes. So again, one icon could serve different function. So it's also related to this principle of clarity, because you have a constrained screen. As you can see, guys, it's all interrelated. One part could be part of many different things, but you still need to organize and distinguish it. For example, I think we have discussed this as well in the previous or earlier. For example, in Microsoft Windows 8, an icon here appears next to the Windows title as shown in figure 17.5. This icon visually communicates the Windows content. For example, whether it's an Explorer window or a Word document, and provides access to window configuration command such as minimize, maximize, and close. So here, the icon in the title bar of Windows in Windows 8 is good example of leverage. It communicates the Windows contents and provides access to window configuration commands. Visual information design principles. I think we'll continue with this because it's too much already. Yeah, things will be more effective if we will continue. But we discuss the main principle. So here, enforce visual comparison. It's still, we're just going deep on that principle. Show causality. Show multiple variables. It's like comparison. Integrate text data in one display. Ensure the content's quality, relevance, and integrity. Show things in adjacent space, not stuck in time. Don't dequantify quantitative data. Consistency and standards of benefits of interface. So we will continue this along with the service design principle that we haven't discussed in the previous chapter. So again, guys, thank you for watching and see you on the next video. Peace.